So the first question you're probably asking is, well, why is he showing us two lines, a red and a green line here, meeting at the point 2, 1, and here are their two equations? And the reason is solving simultaneous equations finds the point by algebra where these two lines, which I'm going to use as my first example, meet. I've basically given you the answer before we do any work. So how would we find that point? By treating these two equations as simultaneous equations and working out their solution and prove that they meet at this 2, 1. Okay, first I'm going to write the two equations down. Now, if we are to solve these two simultaneous equations and find out by algebra where these two lines meet, it's clear even from the diagram that where they meet, they share the same value of y. So whatever value of y is in this equation is equal to the value of y in this equation. If that is true, I can set the right-hand sides equal to each other. This is at the point that the lines meet. So what we've got to do now is rearrange the furniture. I want x's all on the left-hand side and numbers on the right-hand side. So this x will move across to this side, and the 3 will move across to that side. 2x plus x, I get 3x is equal to 3 hops across, becomes positive, and creates a 6 on the right-hand side. Dividing both sides by 2, I can say, therefore, x is equal to 2. And that's the first of the answers we require. And indeed, it matches what the graph is telling us. Now, having got this value of 2, I can pop this into either equation because you see, either equation would give us the corresponding y value, a value of 1 we expect. Choose either one. I'm going to choose equation 2. So you see the advantage of labeling these equations because you're telling the examiner exactly what you're up to. Using 2 sub x is equal to 2. And therefore, using 2, y is equal to negative 2 plus 3. And therefore, y is equal to 1. And there we have the second part of the answer, which happily matches our graphical diagram here. We've solved two simultaneous equations. Now, it's true to say you will never get an example as easy as that one in an exam. And what I mean by easy, they won't just give you a single y that you can just equate the two right-hand sides and away you go. They will multiply the y by different integers and maybe even move things around from the nice form of y equals mx plus c. So you'd have to do a little bit more work to solve those equations, but basically that's the technique. They're asking, where do these two lines meet? Let's move on to a slightly more complicated arrangement. We've got two different lines here, and I've given you the answer. They meet at 2, 0. And I'm going to show you their solution in two different ways. And the first method I'm going to show you is very similar to the simple solution we've just dealt with. And this method is called substitution. And what you do is you pick one of the equations and make y the subject, a single y. If I pick 2, therefore, dividing through by 2, I get y is equal to, divide this by 2 is negative 2x plus 4. So I've got y from the second equation, and I'm now going to substitute that and replace the y here with negative 2x plus 4. So sub in 1, you can see the advantage of labeling those first two equations. And we get 4 lots of this, so is equal to the right-hand side of 1, which is 3x minus 6. Multiplying this bracket out, remember the 4 is going to influence that guy and that guy. Okay, this is going to be negative 8x plus 4 times 4, 16, is equal to 3x minus 6. X is all on one side. numbers on another. I'm going to move the 8x across to the right-hand side, so this is going to give me 11x. And the negative 6 is going to come on to the left-hand side. It will change its sign to positive 6 because we're going to be adding 6 to both sides. And I get 22 is equal to 11x. And you can clearly see, if you rearrange that the other way and then divide through by 11, we get x is equal to 2. And that's the first result. And indeed, it's the result we were expecting. So all I've now got to do is substitute x is equal to 2 into either of these two equations, just as I did before. Let's choose equation 2. And what do we get? 2y is equal to, this is 2, so it's negative 8 plus 8, and that equals 0. Therefore, y equals 0. And that's the second answer we require. We've solved those two simultaneous equations. So the second method I'm going to show you here is a method which is named elimination. And let me write down the two equations again. Now, the aim of this method of solving these two simultaneous equations is to eliminate one of the variables. If I was to multiply equation 2 by 2, I would get 4y here. And if I then subtract equation 2 from equation 1, the y's would disappear. Why can I do that? Well, both equations are effectively seesaws in balance. In other words, the left-hand side matches in weight, as it were, with the right-hand side. And that's also true of equation 2, the pivot being the equal sign. Okay, given that they're in balance and I've multiplied equation 2 by 2, I can take whatever's on the left-hand side away from whatever's on the left-hand side here, provided I do the same to the right-hand sides. So let's multiply equation by 2. So this is going to be equation 2 dashed, let's say. So I get 4y is equal to negative 8x plus 16. So if I now take equation 2 away from equation 1, we will eliminate the y's. Let me come over here and do it. So this is a large, big negative sign here. In other words, I'm subtracting all of these terms from the terms above. 4y take away 4y is 0. 3 take away negative 8 is 11. What you're effectively doing is you're saying 3 take away negative 8, and that's equal to 3 plus 8, which is equal to 11. Negative 6 take away 16 will make the negative 6 drop down to negative 22. And you can see we've got the same answer forming here. So therefore, rearranging things, I've got 11x is equal to 22, and therefore x is equal to 2. And there's that same result again. So having got that result, it's exactly the same substitution that you'd make back into one of the original equations, and you get the repeated answer of therefore y is equal to 0. And there's that second answer. So there you are. There are the two methods, substitution and elimination. Yeah, just looking at it again, yes, we could have multiplied this guy by 4, bringing this up to 12x, and this guy by 3, bringing this up to negative 12x. And then we could have added and eliminated x. It's totally up to you. You just got to spot the easiest way of doing it in an exam situation.